Hello students, resolving power of microscope and telescope part 2. Now here is your first question in this module, and the question is like, the objective of a microscope is first illuminated with a blue light and then it is illuminated by yellow light without changing any other conditions, that is without changing the experimental setup. Now in this second case, what is going to be the resolving power as compared to the previous one? So the options are like, it would increase, it would decrease, it will not change, it would be doubled. So to answer to this question would be very simple and one sentence, that the resolving power is nothing but inversely proportional to the wavelength. That is, if the wavelength increases, resolving power would go down, and if the wavelength decreases, resolving power would go up. So here in this case, the blue light is being replaced with the yellow light. What is going to happen? Yellow light is having greater wavelength as compared to the blue one. So I would say lambda yellow is greater than lambda blue, which would in turn tell me that resolving power is going to decrease as wavelength has been increased. So the conclusion is RP will decrease, and option B is going to be the right answer for this. So this was your first question. Let's move on to the next one. The second question is like, the human eye has appropriate angular resolution of 5.8 into 10 to the power minus 4 radian. A typical photo printer prints a minimum of 300 dots per inch. At what minimum distance should a printed page be held so that one does not see the individual dots? That is, it should appear completely merged, and it should not be resolved or just resolved, it should not be well resolved. So students, this is the same concept of HD. Why we see things in high definition? Because we just increase pixels per inch. So it's kind of same concept here, but here you just need to find out the minimum distance Z. So the options are like 17 kilometers, 12.5 kilometer, 14.5 kilometer and 1.3 kilometers here. So I'd be beginning the solution. I'd be saying like, the printer prints 300 dots per inch, and the linear distance between two dots, let us say it is small d, and I can say that 2.54 upon 300 is, that is 1 inch, is 2.54 centimeter upon 300 would give me exactly 0.84 into 10 raised to minus 2. And this is nothing but going to be my distance, and at what particular distance, that is Z, the particular page should be held would be nothing but determined with the help of this triangle. In this triangle you can see there is a angle phi, which is nothing but the angle resolution of I, and it's nothing but having two sides. In the opposite side it is small d basically, and small d is representing the two distance between 2 points, and there is Z, that distance is represented between the paper and the human being. So if I take tan, I'd be getting something equals to d by Z. So let's move ahead. We would be seeing that the angle subtended is nothing but making tan phi equals to d by Z, and as this phi would be very small, I can say tan phi is nothing but equal to phi is equal to d by z. And students, we know that Z is nothing but d by phi here, and d is what is given in the question, and phi is also given, so we would just substitute it and we would be getting Z equals to 84 upon 5.8, which could be further simplified, and we can get the answer as 14.5 kilometers. So students, this was the question on human eye. Let's move to the next question, and the next question is like, wavelengths of light used in an optical instruments are lambda 1 equals to 4000 angstrom unit and lambda 2 equals to 5000 angstrom unit. What is the ratio of their respective resolving powers? Pretty simple, right? Options are given in the ratio format. We just need to find out the ratio of resolving power of the first one to the other. So we know that they are inversely proportional. So in turn, we would be writing it like, resolving power of first upon resolving power of the second one would be nothing but lambda 2 upon lambda 1, as they are inversely proportional, and lambda 2 is nothing but 5000, lambda 1 is 4000, so it would be like coming into 5 by 4, which is nothing but my option C. So students, this was the answer, 5:4, and that's it from this particular module. Thank you.